Good morning, everybody. Thanks for taking the time to watch our BA4 experimental game intermediate presentation video. I'm Kevin Walter, apparently project lead of this futuristic experience, and I'm accompanied by Tamina Brunke as our designer, Arto Kerwald and Marco Cristoforetti for our programming department, and Sebastian Gerena and me for everything art related. With the team being introduced, let me now give the floor to Tamina.
Continuing with design. As you probably already know, the flipper machine consists of a physical playing field layer and a digital layer. The digital layer of this game enables us to experiment with all kinds of special power-ups, visual effects, and interesting features which are not usually possible in a normal, only physical pinball machine. The game also has a different primary objective than other pinball machines. Instead of playing for a high score, this game has an end boss, which has to be defeated to successfully win the game. However, the player takes damage each time the ball goes down the drain, and obviously the game is over when the player goes down to 0. In order to defeat this powerful boss, the player is able to unlock and buy enhancements such as a third temporary flipper, a controllable turret shot, or regaining lost health points by repairing the ship. Furthermore, on the design part, there were some small layout changes. Even though they might seem subtle, they do make a difference for the overall experience and difficulty of the game. In addition to that, we have a lot of variables that we can edit, which enables us to balance the game even further and fit it to our target audience, which are mostly inexperienced players due to the combination of the actual flipper machine build and the gameplay. So we still kind of have to find the right balance between too hard and frustrating and too easy and boring for new and inexperienced players, but we are definitely on the right way to achieve that.
Hello everyone, this is Sebastian and I will move on with the art part. Firstly, I'll have to say that since I don't have the 3D prints and there is another issue with the physical machine, I decided to focus on the 3D digital elements like the boss shield. This shield was a plain wall and I decided to make it better by following the process I'm used to do. From the sketch to the 3D modeling, but there is a new step for me and is writing the software. I dive into the special effects world, so my first try was by implementing some particle effect to the boss shield with these red hexagons, but in the end it didn't turn out the way I wanted to. That's why I did some more research and I learned to use the Node script to finally animate the boss shield by creating two shaders. The first one used a purling noise to manipulate the vertices and give this special movement. The second one controls the alpha channel and the emission channel to have this cool fade in and out effect. I'm also taking care of the concept for the other elements that we as a group are not so happy with. So I took some more 80s reference as a foundation to start building new elements like the 30D dice, which will be the bombs shooted by the boss, a bumper car that will be the new projectile, and something that I like to call the triple bumper cassette. Lastly, I will do some more iterations in the UI according to the new concept of the shop based on the feedback we got from people that have played our game. Thank you.
Since our first prototype was lacking visual and audio feedback, it was for people unfamiliar with our game quite confusing and hard to clearly read what is happening and why this is happening. By now we added almost all audio effects, which I created from scratch in FL Studio, trying to mimic mainly futuristic sounds from 80s science fiction movies. Besides sound, particle effects are a big part of our game as well. The pinball is constantly hitting or bouncing off from objects, either destroying them, which leads into a particle explosion, or exploding itself. Godot, the engine of our choice, didn't make it easy for me, and after watching all 3 existing tutorials on 3D particle effects, I just couldn't get decent results. Luckily, the concept stays the same throughout all engines, and there are a bazillion Unity or Unreal Engine videos about particles online. I'm still missing some features that the other more established engines are equipped with, but for now I'm quite content with how our particles turn out. Most of the 3D models in our game are 3D printed and need to be colored by hand. But there are few objects, specifically those who move throughout the game, that need to be painted digitally. Although our laser T-Rex is going to be a 3D printed object that will be physically standing inside our box, I painted him first digitally to find out the colors that we actually need. This step helps us keeping the variety of colors fairly low, since miniature painting colors are quite expensive. Lastly, I'd like to present you some of our full screen effects, which make full advantage of our screen's function to completely block the visibility of everything underneath it. We use those screens to show off the depth effect of our box when no one is actively playing. We use them in between the 3 stages and as a game over or winning screen at the end of the game.
Game over. You suck.
Moving forward with programming, I have switched from gameplay programming to solving the 2 major hardware-related issues that are still in the way of this idea of 2-layered gameplay with the moving layer on a screen and the static layer below the screen as 3D printed objects. Namely, the fact that you can't really move around while playing because the perspective is only, or the projection is only aligned with one particular perspective. And secondly, that depth perception means that you can tell that there's a distance between what's on screen and what's below the screen. So you effectively have to, right now you effectively have to stand still with your head in one particular position, and you have to close one eye, which is not a very nice experience. So the first thing I'm working on solving using face tracking. Here's a preview of it. I think it already looks quite promising. Once I get it properly working on the machine, I will move on to the other problem. That one I think is most realistically solved using some sort of 3D vision, probably polarizing filters and glasses. We'll see. I don't quite know yet, but I'm definitely looking forward to that because that's what I've been wanting to do all along. Working on the hardware rather than the game.
As Arthur is taking over the face tracking part, I'm concentrating on the plunger and the flippers. And for the flippers, I did some research about the various motors and possibilities that we can use, and possibly the cheapest possibility. And I found this unusual approach that might be useful for us to recreate. So I bought these car door locks motors to act like some pistons that push the flippers when you press the button, and then retract when you leave the button, and hope maybe this could work. But I already broke my Arduino testing this because of some wrong voltages. So because of that, everything burned, and I came back to Cologne from Stuttgart. And here I'll be working with a friend that actually helped us last semester already with building the box. And he knows stuff about electronics, and maybe he can teach me how to properly wire these motors so that my next Arduino doesn't burn. And then we have also to figure out how to build it inside our box and how to fit it with our elements and screen and all that. The plunger is finally working with this more robust and better potentiometer that I got. I'm getting very consistent and very accurate values compared to the ones that I was getting with the ultrasonic sensor I was using last semester. And I also built this wood holder so that we can easily build it in the box with some more woodwork, or maybe with some 3D prints or even some Legos. Thank you for listening. I hope you liked our presentation, and now we're ready for some questions.